Assalamualaikum. Here today I'm going to discuss about the electric field and magnetic field for Edexcel IAL unit number 4 topic. I'm Ayaz Ahmad Quraishi at the platform of Fizzbridge, and hope you people will find this video for best of your benefit. So here I'm gonna discuss some of the points with you from the given topic, and then we will be discussing about all these areas of the video that what we are going to discuss here. First of all, I will talk about the electric field, then I will talk about magnetic field. The front page you are going to see, that is basically from your book, okay, the student book 2. And by this page, what I have shown you, that what type of vocabulary what we must have to go through this topic. So first of all, we must know about the electric field, then we must know about electric field lines, then field lines, electric field strength, then electric potential, then potential difference, and then equipotentials. So these all are almost 6 points to remember, so I will discuss all of them one by one. So here there is a brief introduction about all these points. One of them is the electric field. So electric field is basically the region, or the space around a charge where a charge particle experiences a force to the other one. So this is basically your electric field. Then lines, they show the direction of the field or direction of the force. Then electric field strength is basically force to the charge ratio, how much force is experienced or exerted by a charge when it is placed in electric field. Then potential is actually the work done by an electric field on a unit positive charge. And potential difference is basically that energy stored in a charge when we bring it from one point to another point. And then equipotential surfaces are basically those positions on a surface of the charge which have same potential. So this is what I have to explain in my further slides. So here we have discussed another important point, that before going to this discussion, or before involving in this discussion, what I wish for the students to learn, that they must know about the gravitational potential energy, they must know about the electrical charge, then potential difference, and electrical energy. These are the 3 or 4 points which we now by all means. Here I have shown you some sort of electrical charges appearing on the clouds, and electrical discharging appearing that takes place through these clouds to the ground. So this is electrostatic discharging or lightning bolt. So due to the difference of potential, that all is taking place, and electric field is being developed between the charges over here and over here. So we will discuss that all in detail. And here there are some sort of important things what we are gonna now about this chapter. Then electric field causes the force on the charge, yeah, this is one of the point. Then we will be discussing about the Coulomb forces and its effects. Then uniform electric field expressed in terms of the voltages. Then the electric field on the spherical charges, yani radial electric field. And then how to calculate the field strength and potential, and draw the electric field lines on equipotential surfaces as well. And then electric field in different combinations, and then Millikan's apparatus, which is actually the application area. So do you see, this is basically a sort of device, defibrillator, which is being used to provide the artificial heart beating, you can say, that is electrostatic discharging mechanism. So by that we can manage the heartbeat again. And this is basically Van de Graaff generator. When you touch it, you feel a huge voltages on your hair, so that is why they repel each other, and that is why it seems that, oh yes, you have all these clumsy hair. Now here what you will study later, and that will be related to the same topic, that is charging and discharging of the capacitor. That is basically the part of this topic, but I will discuss that in later. And then generating electricity in electromagnetism, that is basically the outcome of this topic. And then the alpha particle scattering in the electric field. Then accelerators, which are basically used to develop different type of charges. And then comparison with gravitational field. So these all are the areas. So here I have shown you 2 diagrams, 2 images actually. In the first one, I have shown you that there are 2 parallel plates. They have been represented for the charges. Upper plate is positive charge, lower plate is negative charge. And in diagram B, you have these electric field lines, which actually over here, if this is positive, this is negative, So sorry, this is positive because it is red terminal, this is negative, it is black terminal. So the field lines, did you see, if the, although the arrows are not being shown here, but we can say that the diagram, I mean these all charged particles, they show that yeah, they are aligned in a specific way. So actually this is the force on these tiny particles from the positive plate to the negative plate. And did you see that here the field is appearing as the strongest? So sorry, when later on we developed that appeared in this way. So this is what I will discuss about in detail here. What are the main learning objectives in this situation or in this topic? Here we have two different areas. Define the electric field and electric potential, then using that equation of E is equals to F by Q for electric field strength, and then describing the concept of uniform field and the factors affecting that uniform field strength. E is equals to V by D, the electric field strength on a parallel plates of the on the parallel plates. Here we go. For example, if I have, this is a part of the X-ray machine. Electric field is utilized here. This is a cathode, this is an anode, and here some sort of electrons are being liberated from the cathode, which is at 0 volt, and they are accelerated with a very high voltage, plus 45,000 volts by an anode. And here they pass through this gap and they strike here and they generate the X-rays, that is the target metal, tungsten metal. Basically, this is an idea that electric field lines are always from positive to negative terminal, or that terminal is the positive one, positive which has the higher voltages. So in this regard, I will write down two important things. More positive is positive. Okay, more positive is positive. If one is less positive, one is more positive, then which one is more positive? That is your positive. And more negative is negative. Yani, if I have two plates, I will explain that in detail, don't worry. If I have two plates, one plate is here, that plate is basically of 12 volts, let's say. This plate contains 12 volts, this contains minus 2 volt. So this will be considered as positive, this will be considered as negative. But if I have two plates, one is positive 12 volts, the second one is positive 18 volts, then this is considered as positive, this is considered as negative. So electric field lines will be from more positive to the less positive. Third, if I have two plates, this is, let's say, minus 10 volt and this is minus 12 volt. So minus 10 is less negative, minus 12 is more negative. So minus 10 will be considered as positive and minus 12 will be considered as negative. So that is why the field lines will be flowing from, or they will be directed from less negative to more negative, and here from more positive to less positive. Okay, so this is how the electric field lines are being drawn here. Then here is the statement of electric field, that electric field is basically a region around a charge in which or within which it experiences a force, or it exerts a force on any other charged particle, right? And then we have some sort of electric field lines. Actually, the electric field lines are the imaginary lines either around a charge or around a spherical charge, I can say. Let's say this is a positive charge, and if I place a positive charge around this, then this charge will be basically having a sort of field lines here. This is the area within which that particle, or this particle exert a force on another positive charge. Positive charge is actually your test charge. So what will happen, if you see that if I have placed a positive charge, sorry for this inconvenience, I will just draw it here, this will be repelled, right? In the same way, if you place the positive charge here, it will be repelled, here it will be repelled, here it will be repelled, and so on. So in this way, if I place the positive charge at different positions, the positive charge will be repelled by another positive charge. So that is why the direction of the force is here. This is actually the force direction of the force on the unit positive charge or a test charge. So that field, that lines are those lines which show the direction of force on a test positive charge. They are called your field lines. Hope that it is clear to you. Now, they are always from the positive charge to the negative charge. as I told you, this is more positive, more positive. Here I'm going to show with number of charges, it is more positive, this is less positive. So that is why the field lines are in this way. So this is basically another point from these field lines. If the field lines are stronger, yani they are concentrated, it means the field strength is greater there. Okay, if the field lines are stronger, it means that the field is field is stronger, yani these field lines are closer to each other, so it means here the field is stronger. But on the other way, for example, if we have two plates, and these two plates have the field lines separated by each other at a far distance, it means this is showing a weak force. So this is a weak force and this is a strong force, right? So the strength of the magnetic electric field lines show the concentration of the field lines shows the strength of the field. Now this is electric field strength. So field strength is basically the force per unit positive charge. This is very simple to understand, that if I have a charge for which for which I'm gonna experience, or for which I'm gonna find out its field strength, then I will place a unit positive charge around it, and then I will figure out that how much force of repulsion is being experienced by this charge. So this force per unit positive charge is equals to its electric field strength. So generally, because electric field strength times here electric field is equals to force per unit charge, so this will be multiplied here, so you will get that F is equals to E times Q. So the electric force can be find out by the multiplication of electric field strength and the charge passing through that. So basically, if I say that according to Newton's second law of motion, the electric field can cause electric fields or electric force can cause an acceleration on a body. So the force which is equals to ma, and here the force is equals to E times Q. So that is basically the acceleration can be determined by this EQ upon m. So EQ upon m is actually called charge to mass ratio, right? We call it charge to mass ratio. So hopefully this will be clear to you. Here is a worked example of to find the electric field strength and electric force. So for example, here some sort of we have to yes, the electric field strength is 4.5 exponent 5 Newton per coulomb. It is Newton per coulomb, but you can also write volt per meter. Later on I will tell about that, why I'm using this unit. So here we go. When you will multiply that number with the charge, you will figure out that how much force do we have. So if I have the different this negative sign shows that the force on the charge, yani on this electron, is causing an acceleration towards the more positive of the field. Okay, so this is the opposition, or this is in the opposite direction of the conventional field direction, which is like electric current goes from positive to negative. That is why you are getting this sign. So hopefully that will be clear to you. Now if I use the same situation or same information to figure out this idea, how fast will the electron be traveling if the electric field if this field accelerates that electron from rest, and it is within the field of the distance of 10 centimeters. So here actually I have to use some different concept of kinematics, and then I will figure it out that yes, how will I change that. Okay, listen. Yes, as I want to know the speed of the electron through that distance, so I must have a sort of equation which would link speed and the distance, and that is your third equation of motion. V square is equal to u square plus 2as. Here it started from rest. Here it is mentioned that the electron is started from rest. It means this u will be 0, and now you will be with the equation v square is equals to 2as, where v is equal to 2as square root, and you know that is given that 2, and what was the acceleration? That was force per unit mass into distance, and that means 2 into what was the force? That force was electric field strength into q divided by m into s. So this is that formula which has been derived for you, and now you can apply that formula here to figure it out, the speed of the charged particle, and that is 1.26 exponent 8 meters per second. So almost closer to the speed of light, because speed of light is 3.0 into 10 to the power 8, so it is 1.2 or 1.3 into 10 to the power 8. So this is what we can find out the charges. Then in next video I'm going to explain you the electric potential energy and electric potential. Hope this entire discussion was clear to you and coming back to the point.